Sorry guys, there was an issue. I had to restart the stream. I'm trying to book it to get it. Everything. Oh. Reverb. Hello, Rusted Monkey. Thank you. Welcome. Hang on. I just need to repost with the updated stream link. Discard. And then I'll be right there. Change thumbnail. Alright. Oh boy. What a day it has been so far. Give me just one more second. Okay, I think we should be good to go now. Make sure the link goes to the right thing. Hey, how's everyone doing? Rusted Monkey is first. Good for you. All right. Wait, one more thing. How's my audio? Everything okay? Rusted Monkey says, I was following how you were coding last big stream you had on YouTube. The framework is awesome from a novice viewpoint. That's great to hear. That's definitely the goal. So I can only imagine how powerful it'll be once I learn more. Yeah, it's one of those that I basically can't make Unreal games without it at this point. I use it so intrinsically in everything, and I can make stuff really quick. Now, give me 1 second. You're going to see how the sausage is made a little bit with my controls because I got to fix my camera. That should be good. I don't know why my eyes are still closed. Is the lighting that bad in here? All right, whatever. That'll work. So, today we're going to be going over the new updates in Omega Game Framework 1.5. Alvin says he does like NSFW and Real Engine games. Well, admittedly, that's not the type of stuff we do here. But I don't place any restrictions on principle. I just don't place restrictions on what people make with Omega. So, right, we're going to be going over the new updates in Omega 1.5, which is now finally available on the marketplace for all the updated all the versions of Omega Game Framework. Well, 1.5 is available for Unreal 2 and 3. But the point is, Omega is now available in the marketplace up to 5.3, so up to the latest version. So you can all go get and use it and no longer have to manually rebuild from GitHub. Let's take a swig of some Coke. I love my Coke. All right. So today I'm going to be... there's a lot of things that have been updated, improved, and changed in Omega since 1.3, which is, I believe, the last marketplace version. To the point where I can't go over everything, especially since a lot of it is like all sorts of small details and little things that you'll have to look through GitHub to get all the minutiae yourself. But there's a few key things I wanted to go over that I don't believe I've really talked about and have been updated recently. Hey, Holy Ninja. Hello, Caius. How's your Devil May Cry playthroughs? So not to distract too much, I will say I finished the first one. It was good. I got like 70% of the way through the second one, and it crashed, and I couldn't have the energy to finish. So I'm probably going to start the third one pretty soon. But, all right. So, let me pull up the list. So, we are in Unreal 5.3 right now. And of the changes I want to show, there's the first one I want to talk about is a very simple one that we will go over, which is, if I can find, that's not that, content browser. It is save game screenshots. So Omega Game Framework comes with a built-in system for saving and loading your game. I don't think I've gone into this in detail, but essentially, well, just a refresher of how saving your game works in Omega. Excuse me. Whenever you start up the game, it automatically creates two files. One's an active save, one's a global save. A global save is created the first time you boot up your game and exists on your computer permanently. So it's a way you can store permanent values that'll only get removed when you manually delete it. An active save only exists as long as the game is open and it then is removed, but you can manually save that out. So this would be, game save specific things like, your character name and character properties and, things that would only be for a specific save game file. So that's mainly what we're going to want to work around right now. If you hear a vacuum in the background, I apologize. Sounds like someone's doing some house cleaning. So that's basically the basics of how save games work. Now, one thing what was added with the newest version was save game screenshots, because in order to save a game file, all you have to do, since you permanently have an active save running, all you have to do is go out and say save game, save active game, and then it'll automatically save whatever's in this file to your save game slot by a number. And I'm thinking of maybe changing this to be a string later on like it is normally, but for now it's just going to be a slot number. Well, whenever you do that now, it'll automatically save out a screenshot as well. So that you can then load that in and have a visual display for the player of what exactly was going on in the game. In order to access that, you just have to say get active save, and I believe it's get save screenshot. Now, this will be loaded whenever the active game is loaded, and I believe it may take a second or two to properly load in. So you may not be able. You only may need to give it a second to load in, so you can add it to a widget or something. But to demonstrate this, let's just go ahead and say save game, save active game. Whenever I say keyboard, let's say Q. I'll hit Q. Not print. We're gonna print out and just let us know. Game saved. I'll hit Q. Oh, it does not appear to be working. I'm not sure why. Alright, well, I don't know why that's working. Looks like there's an input issue. But the string is working, so instead we'll just do it this way. Sorry. Ignore this. This is just for testing purposes. Sequence. Delay. 1 second, and then save. I didn't see anything get printed. That's weird. Well, we'll check this folder anyway. So what should have happened is if I go into... That was... Give me a second. What the heck? Let's see. If I go into... I think it's the save folder. Test. Saved. Saved games. Right there. We have our save game file as well as the screenshot it took. Right here. And so this will automatically be loaded in whenever you load up that save game. So you can apply it to a widget and, give a representation to the player of what was happening when they last saved. I don't know why print string didn't work. So I'm guessing the thing did work before and just the print string didn't function for some reason. Oh, well. All right, what's next up? All right, well, on the topic of saving the game, there have been a lot of other small improvements to your save options. Let me pull one thing up quickly. All right, so let me pull up the list. So you have a few things that have been added to your save game. One is playtime. Let's see, playtime. Automatically, whenever a save file is started, it'll begin tracking the save time, and like adding on to the current save time. Now you get this as a time code, but you can also have it as a string. Where is it? Get playtime a string, so that you can display it in a widget and show how much playtime the player has played so far. There's also been a new improvement to data assets, which is let's see, saving tags to a data asset. I think you can remove tags as well. And this is just a way where you can essentially bind tags in your save game to a data asset. For example, maybe you have a specific a data asset that represents a character in the game, and that character is being killed. So you'll want to give him a tag that says dead, and by referencing a save a data asset, you just can reference their character data asset, and it's just a very easy, streamlined way of handling that sort of thing. So that like if maybe you don't want to reference a specific actor because that character could be on multiple actors across multiple levels, so you want to save it to their character asset instead. Now, in addition to that, all the functionality for saving data assets, so data asset collections or data asset tags, has now been copied to work with GUIDs as well. So for those of you who don't know what a GUID is, a GUID, I forget the exact term, what it's an acronym for, but it's essentially something built into Unreal Engine. It's a global identifier, essentially. It's a long code. I can even show you here. That is used. Let's generate a new one. That is essentially used as a unique identifier for a specific object in your game, and this is used for all sorts of things. But this was inspired by a request from someone on my Discord, who I will try to pronounce this correctly. Naturinis, I believe. Naturinis. That's how I think his name. We'll just say that. Sorry if it's wrong. Is pronounced. Anyway. He made a request for an inventory system that essentially didn't use the normal inventory system. He wanted more flexibility with it for specific like item references and things. And data assets kind of limit that. Data assets are good for a case where you never modify items, for example, where every item has set values, static values. But if you want more control over your games, for items in your game, for example, you might want to use something like GUIDs, where every single item has a GUID, and then you can modify parameters on that GUID specifically. So I have added that to save collection or the save game, and it works the same way that saving data assets does, where you have a few options where you can a set of GUID is collected or not collected, which will just add it to an array in the save game, or that could be very simple things you just want to collect and not collect, or you can add tags to a specific GUID. How you want to use this, totally up to you. There's all sorts of ways you can use it, but it's a streamlined method, and also there's easy ways to check and see if the GUID is collected or if it has tags, say with data assets. Just trying to make the process of saving and loading data much easier. Let me pull up the thing. Speaking of making saving and loading data a lot easier, in addition to all that, probably the biggest addition to saving a game, which has I believe been around for a little while, but I don't think I've talked about it, has been the use of JSON files in order to save and load data. JSON essentially is a how do I put this? It's a more conventional way of storing data and information across all sorts of not just games but software. And it's, I think, a much easier method for... I won't go into how JSON works, because honestly that's something you probably should look up on your own if you don't know. But assuming you know how JSON works, I've essentially streamlined the process of saving game data using JSON files. And this, I think, has allowed me to make features more modularly and more, I guess, reliable. And more viewable, where you can like open up a save game and see specifically what your JSON values are. So, of the JSON additions I have, I think we'll first look at what I'm calling the quick set, or quick set and quick get JSON values, where if I just type in JSON and it'll go down here, under Omega JSON, we have a few different, so we have a few different options for setting and loading values. So we have global JSON, which I think... Well, let's just run down the list. First, we have global JSON fields, which I believe are bound to your game instance. So these are global properties you can set that'll exist as long as your game instance is active. We also have JSON field world, which will exist as long as the world or the level you're in is active, and then those properties will be reset. And then, more significantly, we have active save and global save, and these just make it much faster to save data to and from your game. By just using JSON fields. And because they're a wildcard, you have all sorts of options. So let's just say I in this game, you could decide your character's age. There's a lot of ways you could save that, but probably the easiest way would just be we get this JSON active save and say player.age. Let's just get a literal, I think it's int, and we'll say their age is just old enough to drink, 21. Copy that over here as well. Then whenever we want to get that, we just go get JSON field active save, and obviously it'll need to be whatever the same location is that was before. And we can get the player's age from there. And again, because it's wildcard, you can set all sorts of different things in there. Running down the list. Let's see. All right, so that is essentially how JSON works. JSON saving works. That's the quickest way to do JSON saving, and you can do it for global saves as well. The other method is using what I will make a new actor for. Actually, let's put up the test game system. Is using I'm trying to remember what I called it. Save game registry, I think. So this is essentially a way where you can it's an interface. So save game registry. Sorry, let me back up and start again. JSON save game registry is another feature I have added, and it's an interface that you can attach to any actor or any object in the game, and then register it as a save target. Meaning, whenever you save the game, it'll attempt to save data from that target specifically, and allows you to design things more modularly. So to demonstrate it, here I have this is just the map, but it should work fine. All you need to do is do, I think, the Omega save interface. And then right here, you can have use JSON save data. Check that to true, and we'll give a save name. This will be whatever. This will be the JSON field that all this data is saved to. So let's do test data. It doesn't really matter. Now we have load JSON data and save JSON data, and this means whenever the game is either loaded or rather started or saved, it'll run through these functions. So, for example, if I wanted to save JSON data out here. Let's say I wanted to save the player's location. Let's see. Well, no. Set field player location. Get actor transform player pawn. Pawn. And we'll need to make sure to set that back out. So now whenever the game is saved, it'll run through here. And whenever we load the game, we'll say get field. Where is the thing? Player location. Set actor transform. Not the sky sphere. Get player pawn. And here you go. You have this right here, and now it'll set the character's location to whatever the location was saved to when you saved the game, just as an example. Now, in order to use this, we have, where is it? Begin play. You'll need to register it as a save source first. So typically on begin play, let's do save subsystem. Getting save subsystem, we'll do register set save source registered, and we'll use this object. That means it'll add this object, which in this case is the level, so we wouldn't normally do it in here, but whatever. This object to the list of things to take into account when we're trying to save and load data. And this allows you to design stuff more modularly. For example, gameplay systems, one of the features in the game, automatically, have this save interface implemented. So you can automatically set up a modular system like I don't know, an experience system or an achievement system, for say, that maybe you wanted to transfer from game to game, and then you would just go like achievement. Where is it? Save JSON data, and put in the stuff here. Oh, and also it is automatically registered as a source. Gameplay systems are automatically registered as a source, so you don't need to do that manually here. But yeah, then when you could easily pass around from game to game or decide to turn it on and off depending on what if you decide to change your mind about how the game works. So yeah, increasing modularity made things easy to use. All right, so that's it for saving improvements. Next up, object sorters. Object sorters are something that came out of the fact that very often I would need to have different methods for sorting and filtering a list of objects, and I wanted them to be reusable. Let's go into here. For For example, maybe you have RPG as the example I like to use. Maybe you have different categories of items. You have consumables and equipment and key items and blah 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 blah. And you want to be able to take a list of say item assets and remove things that don't belong in whatever the category you want is. Or perhaps you want to, as the name suggests, object sorter. You want to sort those objects by a certain method. For example, you want to sort all objects by their alphabetical name or by how many are in your inventory. That's where you would use an object sorter. So an object sorter comes in two parts. First, let's go to miscellaneous. Get the data asset called a Omega object sorter asset. And we'll call this sorter equipment. Probably won't go full demonstration on this, but then you can give it things like normal, like in most things in Omega. You can give it a name. Like if you were putting it in a list of category options, you'd want a display name. You can give it a description, an icon, label. And then you can have this needs to be updated. So this is something on my end. Ignore where it says name. This is supposed to be a script. You have a script that determines how the sorting process is done. So for example, one of the default ones is alphabetical. This is just shows the order. If we run a list of objects through here, it'll attempt to sort them by their display name. So in this order. So like Z would be at the bottom, 0 would be at the top. We have things for, gameplay tags, which allows you to filter out objects that do not have the tag properties you want. Literal asset list. This is a little different. This is literally just gives you a list of assets and then outputs it. But anyway, you have a few different options here. So in this case, we want to say, let's say, whatever objects we filter through here have to be of the item.category or the item.equipment tag category. So let's see. Let's open up the level blueprint to demonstrate. And you can also, because these are instance, they're customizable. You can set up your own types. So let's say sorter script. I think it's sorter script. What's it called? It's been a while. Slot script. Let's just look up sorter. Sorter class. Let's say sorter. Has dumb tag. Let's just do it that way. Just to demonstrate, we'll say filter objects, and here are the two functions. You have should checked object be sorted first. It's just your method for determining how you want to sort these objects in what order. Then you also have filter objects, which lets you remove any objects you don't want. I don't know. No, not that. So, and obviously because they're instance, tad, whatever. Let's just make it an integer because I'm just trying to demonstrate how it works. Because they're instance, I can add it right here and adjust the properties. Now, to actually use this, all you have to do is wherever you want to use it. We'll have an array of objects, an array of objects. Let's just say, I don't think I have any. Let's just do data assets. We'll grab a list of them. It doesn't really matter if anything's in it. Then in order to use it, all you got to do is look up sort object array. You drop in the list of objects. You can add in a context, which is optional, and that's just if you want to have some in sort of logic for how stuff gets filtered. Totally optional. But there you'll also select your sorter. So in this case, we'd have our sorter equipment, and then it would output whatever values it has after it's done sorting. You can also determine an output class, which just determines what this output type is going to be to make that process even easier. So that's the object sorter. What else do I got? All right, last thing I want to go over. This is probably the biggest thing outside of arguably saving, but this is scripted effects. Now, Omega Game Framework already has a system built in for gameplay effects. This is obviously you just go ahead and create. It's not there. an Omega gameplay effect, which is an actor, so you can add components and stuff. Effect. We'll say poison. Whatever. But point is, this is currently how effects work in it. You create an actor, and then you have options in here for running the actor, like you can add tags, effects you want to remove it, or want to remove when this actor is applied. You have a pop-up. You have a damage formula, which determines damage. Now, this is how effects worked previously. The problem was it was pretty restrictive, not very customizable, because a lot of times I would want to modify specific elements of an effect, like what attribute. I would want to keep most of the properties of an effect, like how its formula was calculated, but I want to change small things like what attribute it targeted, whether it did damage or healing, things like that. And because of this being an actor class, that became very hard to do without just without just creating lots and lots of children of this actor, and it became bloated. And I wanted a way of changing that, let's say, on a more specific basis. Let me get a drink and I will keep going. So, for example, if I had a skill, I could have two skills that use the same logic, but one did fire, one did different elemental damage, one did fire, one did water damage, or maybe one did magic damage, one did physical damage, stuff like that. So I wanted basically a way of having more customization, and that's where scripted effects came from. So scripted effects are, well, just that. They're effects that you can give specific scripting to, but then reuse and customize them as you want. So let's just pull up back in the test map. To use them, let's make this thing. And let's say, where is it? Scripted Omega custom scripted effects. We'll create a variable of that type. Then before we do anything with that, let's go ahead and open it up. Now you have two options here: effect assets, which are essentially prefabs that you can create, and then custom effects. And this is where most of what you'll be doing is. Custom effects, here you have these specific effects you can do. So we have apply effect, which should be apply gameplay effect, and this allows you to apply a gameplay effect like I did earlier. Then you have the more interesting stuff like compared attribute damage, for instance. So this is one that will calculate the power of an instigator's attribute, then subtract the target's attribute from it, and then that will result in the damage. So, for example, how I handle attack in my game, or normal weapon damage, would be, say, the instigator power of basically the instigator's attack value times 1, minus because it subtracts the target from the attribute, minus the attribute's defense, minus times 0.5, and then that'll damage their health. Then I can also have variance on how big of a randomization difference there is, as well as max damage and the damage type. Yeah, that's just an example. I have also ones like flat damage, which just damages an attribute a flat amount. We have percent damage, which damages an attribute based on its percentage, like 10% damage. And then all sorts of stuff. And again, because these are instanced, you can create them yourself. For example, let's say scripted effect. Let's just say print. I know print wasn't working before, but maybe it'll work now. Anyway, we have different options for can this effect be applied, get cues to play, which this is gameplay cues, which I won't go over now, but if you understand what gameplay cues are in like the gameplay ability framework, whatever it's called, they work similarly. What we want is on effect applied. So in this case, we'll just say print string. We'll just print the target's name. Text color, because once again it's instanced, so we can determine that, and we can go in here and say effect print, and the color we want to print it, and it'll print the target's name. So you get more customization. Now what's neat about this is that it can be used in, well, you can add it to anything because it's a structure. You can add it to all sorts of things. So let me just say, not there. If you use date items for skills, let's say, I think I have a trait for that. Gameplay effects? I don't think it's gameplay. Apply effects. So now, let's say this was a super attack, 2x damage. Then you can, go right into the skill and just apply. We'll say this does 20 damage. You can set up the specific parameters here of what the damage of that skill should be done, or what damage that skill should do, rather than needing to create a separate actor for that as well. So you can contain stuff in one asset. Now, you may still want to reuse stuff, and that's where that's where the effect assets come in. And an effect asset is literally just a prefab containing, where is it? Containing a list of scripted effects. Effect damage over time. So here you just add in the scripted effects, like let's say whenever this effect is applied, it does 1 damage, in which case damage over time isn't a great choice, but whatever. Oops. Then we can just add that right here, and it works the same way. It's just a prefab. Now, there's still a reason to use gameplay effects like this, which I probably need to change the name of, but just because they are attached to your actor, so they can have, some extra logic. A scripted effect is just applied once and then disappears. This can stay persistently on your actor. So, for instance, let's, I called this poison. Let's go ahead and say, oh boy, tick. And let's say every second, whenever this effect is applied, every second we're going to apply. Let's see, where is it? Yeah, script dead effects, and we are going to flat damage. So we're going to every second when this gameplay effect is applied, we're going to do 10% damage to the player character. Whoop, 1 second. Sorry, just checking the chat, making sure there's no issues. All right, so to apply this, we just go apply scripted effect, and we set in a target and an instigator. In this case, I'm just going to have the target, who will be whoever this effect is applied on, will be both, because I don't think it matters. But there, you just apply that. And now, in fact, let's not even do that here in the effect. Let's just go ahead and do that test map so I can show you exactly how it works. And we'll say get player combatant. So I believe, let's do 2. Let's have the print and the flat damage. How about that? So I can test the one I made as well. Remember, health. So 10% damage every second. Now if I just do play, I'll go away. Sorry, that's an issue I gotta fix later. There. Now it's doing it's doing flat damage, so it's damaging me 1 point every turn. We don't want flat damage then. We want, where is it? We want percent damage. And we're going to damage their health, no, not defense. Damage their health 10% every second. So now, boom, there you can see. So it gives you a lot more customization to how you have effects applied to a character. And that's the last big thing I want to show off. Now, like I said before, there's a ton of smaller changes that you'll probably need to consult the GitHub for, but these are the main ones I wanted to hit on. And yeah, so as was that. Reminder, 5.3, Mega Game Framework, the latest version, 1.5, is now available for Unreal 5.3. So up to the latest version, you got all these changes and everything else. Good to go. You can download it, use it right now. So with that said, I think that'll be all for right now. Thanks to everyone who watched. I hope you got a lot of use out of this, and I will see you all later.